Welcome back to the Math of Video Games. This is our third episode. We're going to be talking about movement. So in our last video, we talked about position, and we said that every object in a game has a variable which stores where that object is in space, whether that's 2D space or 3D space. So in 2D, you might see something like position equals 3, 2, or in 3D, you might see position equals 3, 2, 5. So let's answer the logical follow-up question, which is, how do we actually make things move? Well, let's go back to our 2D position first. We have position equals 3, 2. Right now, we're just sitting there. If we want to move to the right, which value would we need to change? We need to make the first one, the x value, go up. So we just went from 3 to 4, which means our character moved 1 unit to the right. Just like that. But that's just one step. How do we make something move continuously? Well, instead of manually setting that number every single time, a full brand new position of position equals 3, 4, position equals 4, 4, position equals 5, 4, we can update the position based on what it already is. Once again, thinking about how we learned about variables in the first video, we can reference that position variable. So we could say something like position.x equals position.x plus 1, or if you recall a shorthand we learned, position.x plus equals 1. So let's just break down what's happening real quick. We're taking the current x value and we're adding 1 to it, and then we're storing it back into x. So if we start at position equals 3, 2, then after one update, after running that line once, it's going to say position equals 4, 2. And then after another update, it'll say position equals 5, 2, and so on. So as long as you are repeatedly running that line of code, position.x plus equals 1, your character is going to repeatedly, plus 1 off and to the right. If we wanted to move, say, upwards instead, how would you write that out? Let's keep using increments of 1 for now. This shouldn't be too difficult of an exercise. You only have one other option of something you can change. Instead of the first number, you're going to change the second one. But remember, there's a shorter way to write this where we can just reference our variable. You could say position.y plus equals 1, or if you did the longhand, position.y equals position.y plus 1. So if we wanted to move up diagonally, upwards and to the right, we could just add plus 1 to both. We could do position.x plus equals 1 and position.y plus equals 1. Instead of hard-coding plus 1 every time, we create another separate variable, which we can call velocity, which allows us to change how fast we're going to move in whatever direction. So we could initialize or create velocity at the beginning to say velocity equals 1, 1, which means whenever we apply velocity to our position, we're going to say move 1 up and 1 to the right. Now we can write something like position equals position plus velocity. That one line is doing exactly the same thing we were just talking about with position.x plus equals 1. But now it's flexible because we can change velocity. For example, we could change it to velocity equals 0, 1. Now we're going to just start moving upwards. If we set our velocity to be 1, 1, we're moving diagonally up and to the right. We could also change velocity to be -1, -1, and now we're moving downwards diagonally to the left. So you can imagine a scenario here where maybe our character jumps forward. They're moving to the right and they jump. Then that's going to be plus 1, plus 1. We're going to have our velocity be 1, 1, so that we're moving up and to the right. But then let's just say the player lets go of the controller and now their character is falling off a cliff. Well, the velocity should change to 0 because we're not moving left or right at all, and -1 because we're moving down because of gravity. It's a simplified version of kind of how that would work. So the next trick we need to really figure out is how we repeatedly apply these updates to our position over time. Because in games, we're constantly doing position plus equals velocity, position plus equals velocity, position plus equals velocity, over and over and over again. It's not a thing that happens one time. We need to always know what that velocity is, even if it's 0, and make sure that's what we're applying to our character's position. Let's just try a little exercise. Let's draw a 2D coordinate grid like we did last time. And for now, let's have our starting position be 0, 0. Now choose a velocity. For example, you could do the easy one, 1, 0. Now each step, add the velocity to your position. So step 1, 0, 0 is going to go to 1, 0. Step 2, 1, 0 is going to go up to 2, 0. Step 3, 2, 0 is going to go to 3, 0. You're moving to the right. You should see your little dot just moving 1 over every time you do a step. But now try a different velocity and you'll see how we can apply speed in this way. Try something like 3, 1. Now you're moving much faster to the right because every step you're going 1, 2, 3, 1, 2, 3, and you're moving up by 1. So you're slightly diagonally going upwards and moving very quickly to the right compared to what you were doing before. So in essence, movement in games is created by updating a position very, very quickly, usually dozens of times every single second. This normally happens every frame. So if you've ever heard of frames per second when talking about video games, then you'll know it's very common for games to be run at 30 to 60 frames per second. This would mean our position is updating 30 to 60 times every second. So you can imagine how fast we can make things go and how it looks so smooth. But right now, that means our movement is totally dependent on how often this update is happening. So that being the case, different machines might be running at different speeds. So you can imagine if something is running 30 frames per second and we were saying our velocity should be, 3-1, and that should run every frame, well then 30 times 3, you're moving to the right 90 units, whatever that looks like in game. But that would mean that someone who's running at 60 frames per second is going 180 spaces to the right or units to the right, which would mean that someone whose computer is running twice as fast, their whole game is literally happening twice as fast from their perspective. That's not good. We don't want that. We want everyone's gameplay experience to essentially be exactly the same, regardless of the performance of their machine. So how do we control for that? Well, that is what we will be talking about in the next video, where we talk about time. Stay tuned.